Good afternoon, and it's my pleasure to start our PhD symposium, next section of our PhD symposium program. And today we'll have a presentation by Taras Yaroshko, Victoria Kosa, Alexey Ignatenko, Alexey Makarenko, and Vadim Yermolayev, Engineering Scientific Knowledge Graphs from Publications, the Anti-Corruption Use Case. Please, Taras. You have 15 minutes for presentation, and we have 5 minutes for questions.
I hope you can see my screen. So, yeah, good afternoon, everyone. My name is Taras Yaroshko, and I also want to present my research colleagues and supervisors, Victoria Kosa, Alexey Ignatenko, Alexey Makarenko, and Vadim Yermolayev. So, the plan for our presentation is as such. I will start by explaining what motivated us to do this research. Then I will continue by showcasing the background knowledge and methodology that we used in this research project, as well as the proposed refinements for the methodology. After this, I will present the research questions which were put forward for the research study. And then I will explain how we set up the series of initial experiments and a report on the early results we obtained. And I will conclude by presenting the conclusions and outlining the brief plan for our future work. So let me start by explaining what motivated us to do this research. So anti-corruption is actually a vibrantly developing field of scholarly research, and it is at the intersection of a lot of important areas with high impact on different communities and nations. And those areas in respective communities include legal, information science, data analytics, healthcare, public administration, etc., just to name a few. So in our opinion, a well-engineered open knowledge graph presenting the methodologies and practices of anti-corruption is of high demand for both the researchers practicing in this domain and just the general individual. And especially we think it's in high demand because of Ukraine's striving for EU and the demand for fighting anti-corruption. And finally, we think that it would be a great starting point if we want to later extend to other important domains such as healthcare, public administration, and business. Now I will outline what background knowledge is used in our research and what is our planned contribution regarding the refinements of methodology. So for analyzing terminology saturation, we took in a collection of papers of the particular relevant subject domain. We took in a collection of the full texts of the scholarly papers. For processing these papers, we used the successive approximation approach. So we took the chunks of papers from the collection and built incremental textual datasets by adding a chunk every iteration. So we aimed at measuring the terminological difference between those successive incremental datasets. Our objective was to saturate the terminology dissolved in the collection if possible. And this terminology could be further used in engineering work. This method is inspired by the grounded theory approach, which is widely used in qualitative research. So overall, at every iteration, we discovered and extracted terms from the dataset. We retained only significant terms using this epsilon as the threshold. We measured the terminological difference between the bags of significant terms of successive iterations. And in our case, the saturation was achieved when the this term-hood difference steadily went below the epsilon. Therefore, as outputs, we received a much smaller terminological core subcollection with a very similar terminological footprint onto this scientific domain compared to the complete pile of papers, but the overall collection of papers was much smaller, but still representative. And secondly, the saturated term set that was representative for describing the domain and could have further been used in knowledge engineering work. However, there were quite a few problems with the baseline TSA approach in case we wanted to expand it to actually building the scientific knowledge graph. First of all, a big issue lied in pipeline inability to distinguish between terms and non-terms. This was a trade-off between domain neutrality and overall term recognition quality. So obviously this approach would have a much lower accuracy in this area compared to some domain-specific deep learning based approach. Secondly, the TSA pipeline is not yet end-to-end for actually knowledge graph creation, because we would need to find some additional solutions for the conceptualization part of the pipeline. And the vision approach we had was to use large language models to kind of combat those problems. And we wanted to also incorporate a human expert in the loop to help with data validation. Another kind of background that we used was the ontolect methodology for ontology refinement, but that's that would be more for the future part of the research. So as for the refinements for the methodology, you can see that on the right of the slide, there is the diagram of the whole pipeline. And our refinements are colored in green here. So they include actually incorporating a human domain expert in the loop for data validation and using pre-trained LLMs to improve this problem that we had with the term recognition in the collected texts. Another refinement for the methodology that we had was to actually create this part for scientific knowledge graph completion. And the mechanism we envisioned was to label each document in this terminological core subcollection that we received after TSA using terms from the saturated term set. Then we would map the documents to the terms in order to identify context for schema generation. And then we would use those term definitions by prompting a fine-tuned LLM with definition and basically asking it to generate an RDF schema of the domain ontology. So now I'll outline the research questions which were put forward for the proposed research. So first of all, as I've already said, one of the improvements required by TSA was the ability to filter out the irrelevant term candidates. And we wanted to understand if an LLM or a lighter-based deep learning approach could be able to perform this with a sufficient precision compared to the outputs from the human domain expert. Secondly, there has actually been a controversy in recent papers reported that LLMs are kind of good for zero-shot knowledge graph completion, but actually are not very good abstract reasoners. So we wanted to answer the question, so could an LLM be used for generation of an ontology schema, such as a UML class diagram from a relevant text of the domain? And lastly, to combine those two questions, we wanted to understand if a combination of TSA and LLM with text-to-graph approach could be used to replace the ontolect phase 2 for quality knowledge graph engineering. And in the current state of the research, we have some early results available regarding questions 1 and 2. So now I will present those early results that we have obtained. So for the collecting relevant papers, the baseline part of the pipeline was used. Overall, we experimented with 2 consecutive runs, and the reason for the second run was that run number 1 has had an insufficient amount of papers which appeared to be terminologically saturated. Those runs shared the same set of seed papers, which were chosen by the domain expert, but however, they differed in the number of OpenAlex concepts, which resulted in the increase of the collected relevant papers. Then, as an input for TSA, the papers collected in the previous part were used as the dataset. These papers were pre-processed into plain texts and split into 40 text increments. And as I've said, we constructed the datasets by putting together the increments from 1 to I for every ith iteration. Based on the graphs, you can see it could have been concluded that the terminological set extracted from the collected papers is actually not saturated. And as you can see on the first graph, those term-hood difference values are volatile and do not really go below the individual term significance threshold epsilon that we defined. So when we analyze the second graph, which shows actually the volatility of the terminological the measures of the terminological volatility, we can see that actually after about 20th iteration, it is in the corridor of plus minus epsilon. And we hypothesized that this saturation blur could be caused by the significant amount of regular accumulated noise. So basically a lot of irrelevant terms that we extracted. And the solution we wanted to check was to use actually knowledge from the pre-trained LLM or domain or human domain expert for kind of semi-automated approach. So for removing noise from those saturated term sets, we decided to use LLMs via such a mechanism. So we fed the list of 200 most significant terms to the LLM, and basically we asked the selected LLMs to return the confidence level of each specific term of how relevant it is to the particular domain on the scale from 0 to 100%. In order to evaluate those predictions, we just compared them with the results from the human domain expert, the classification that was done by human domain expert. And you can see the results on the graph on the left side. And on the right side, you can see that we used such models as Claude 3 Opus from Anthropic, ChatGPT 3.5 from OpenAI, Llama 3 from Meta, and Command R from Cohere. Some of these models were able to achieve up to 85% precision when the domain was mentioned in the prompt. The objective of our last experiment was to find out if LLMs are actually good conceptual modelers. And in order to test this, we prompted these LLMs with the description of the process concept from PSI upper level ontology. The results were as such. The LLMs were able to identify entity types with sufficient precision. However, the extraction of the object domain properties and property constraints failed. So at this point, we can say that kind of all LLMs failed to return adequate UML class diagrams, but actually it's kind of impossible to efficiently evaluate their performance in this area because of just on our first preliminary try. So more research and more effort would be needed to accurately assess their performance using prompt engineering or fine-tuning for the downstream task. So I'm going to conclude by talking about our conclusions and also our plans for future work. So as for conclusions, as for conclusions, we can say that the answer to the first question is that LLMs can actually be used in zero-shot setting for denoising the saturated term sets or an arbitrary scientific domain with sufficiently high precision when we mention the domain in the prompt. As for question 2, we realized that more research is needed to train LLMs or prompt or fine-tune them to become strong conceptual modelers. So therefore, the engineering of the anti-corruption scientific knowledge graph will be continued using the baseline onto elect methodology. And also we will research and engineer other deep learning-based approaches in parallel. And so our plans for future work include improving the LLM accuracy in term classification via prompt engineering and or fine-tuning, as I've already said. Also, we will continue our research and development on domain ontology generation and finally, scientific knowledge graph completion for anti-corruption. And lastly, this is more of a long-term goal. We would like to extend and test the methodology on other closely related domains to anti-corruption. So thank you very much for your time, and I would be happy to answer any questions.
Thank you for excellent timing. Do we have any questions from the audience? Or maybe online? It's not good for me to answer a question because I'm closer. I can answer them. Okay. Are you planning to investigate this approach using more recent LLMs that using line of thoughts, chain of thoughts idea and everything? Maybe it will be better.
Yes, we do plan to use this, and we propose that it would actually be better because the recent development of LLMs is very, very fast, and we would like to be up to date in terms of our results and the models which are actually available. So we do believe that the new approaches used in recent LLMs will be helpful, especially for the ontology generation part.
Okay, also I think that graph LLMs can help. I mean, when you use graph models integrated, this can also. Any other questions? No? Okay, so thank you, and let's go further. And second presentation today is Vlad Yatsuta and Vitaly Kobets, generalized AI-based solutions with NLP support for processing business requests. Please, you have 15 minutes.
Hello, everyone. Can you see my screen? I hope. My name is Vlad Yatsuta, and today I would like to talk to you about processing business requests using AI-based solutions with NLP support. First of all, let me introduce the team behind this research. As I mentioned before, my name is Vlad Yatsuta. I am senior Java developer. I am PhD student in Kherson State University, and I have over 16 years experience in the information technologies as senior Java developer, team lead, and architect. And my scientific supervisor, Vitaly Kobets, Doctor of Economics, Computer Science, and Software Engineering in Kherson State University. Okay. So on this slide, you can see the structure of today's discussion. So first of all, we will talk about our research goals, the methods which we have used in our research, the process of processing business requests, AI-based solutions which we propose, experiment which we perform, and results together with conclusions. So let's start from our research goals. Our main goal was to make processing business requests more efficient using AI technologies. For this, we need to do the analysis of different business requests from various domains, and based on this analysis, we needed to do classification of business requests, and after that, introduce some AI-based solutions, and based on that solutions, we're going to need to build program prototype to test them. So on this screen, you can see the methods we have used in our research. It is artificial intelligence with NLP support, intelligent data analysis, content analysis, and related words analysis. Based on the analysis which we performed, we have defined 4 main points of request classification. First one is amount of required information. So requests can be classified from low to moderate to high amount required. Response format, as you can see, it can be textual response, visual representation, and interactive representation. Regularity of the requests, it can be either one-time, periodic, or continuous update. And frequency of modifications, so requests can be static or dynamic. Based on this classification, we have divided requests into types. First time is the static request. Usually it's periodic static request with moderate to high information demand. And such type of request usually can be fulfilled by scheduling reports. Second type of the request is dynamic one. They require research and analysis from, usually to answer that request, you need to do additional analysis, involving different teams, including data analysts. Usually such requests have smaller format and often take form of the question and answer interaction. And they does not have certain periodicity. So in our research, we have decided to concentrate on the second type and to optimize and the process of the fulfillment such requests. First of all, we have built next schema. This is generalized schema of how requests are processed. So requester send the request to responsible person, and responsible person contact different teams like support team, data analyst, legal team, quality assurance team, and others. They get their own necessary information from database, corporate documents, and sometimes from third-party sources. They return all the data to the responsible person, and after that, he is gathering all the responses, combine them, and return back to the requester. First of all, we decided to optimize the schema. As for most of the companies, they decide to keep all information in their database just to be sure they can take it whenever they need it. So optimized schema looks like that. So in this case, all teams connected to the database, not to some third-party sources on corporate documents. After that, we decided how we can use AI chatbots like ChatGPT, etc., to optimize such thing. First, our solution was to use AI directly. So basically, we have artificial intelligence assistant, which is learning on the corporate data. So all data then go into the database, they go for the AI first. So this solution have a lot of disadvantages. One of them, it's really costly because you need to have your own servers, you need to have multiple teams to support them. And the response from AI could be wrong sometimes because I believe everybody if you use ChatGPT, you face the situation when you ask the question and get the wrong answer. So our next solution were designed to use third-party sources like Gemini, ChatGPT, Claude, and etc. And the biggest challenge which we face is the security. So as it is third-party sources, we cannot send sensitive information to them. So based on the schema, we saw that everything basically saved in a database. So the only things which we need from the AI in this case is means to get the data from database, means to generate SQL query. And also additionally, we wanted to present these response in more human-like way. So we have wanted AI to generate response template for us as well. So on this schema, you can see that requester will interact with interface, will ask the question. The processing model will separate the question and basically get 2 responses from AI, one for a response template and one for SQL, which will go to the database and we get the results. And after that, processing model will combine 2 answers and provide feedback back to the user. So as experiment, we have created 2 program modules, one for SQL generation scripts and one for text-to-all templates. We have created base input. We have tested this solution on multiple test cases. And here are results which we get. So first, So first is the text-to-all template. So what we needed from AI, for the testing, we have used ChatGPT, but we have tested several cases on Gemini and Microsoft Copilot. So answer was pretty much the same. So as a main test source was ChatGPT. So we have tested it using, first we generated textual templates. We have asked ChatGPT to provide us response to the question we have asked using 3 stars as an answer placeholder. And we have asked him, like, provide him some examples. After that, we have run multiple questions. Here are some of them. So, for example, we have asked from different domains, from travel domain, from booking, etc. So, as you can see, we have asked how many tours were sold last year. The answer was correct for us. It was replacing added 3 stars as a placeholder. But when we have asked what is average price of the book, the answer was not fully correct. It is answered, the average price of the book is typically around $3. If we talked about United States, the answer would be correct. But if we talk about Euro, the main currency is Euro, it would be correct. Or if we talk about some other countries which use national currency, will be also correct. So you need to specify which currency used and etc. in base input. Also, we have tested several cases where we need multiple placeholders. The answer was correct. And in some cases, ChatGPT started to answer the question itself instead of providing template. Like you see, what is the time right now, it was trying to answer the question. For this, we have regenerated the chat, re-enter base input, and it start working again. So for SQL requests, the results were much better. So we received, for most of the cases, we have received correct response. The queries which were built, they built correctly. The joins were used properly, even if no foreign keys were specified. So for here you can see a small example. We have tested it on multiple different databases from different domains. So, for example, we have asked him like this complex question: how many bookings were made by female clients with age over 30 in the certain period? So, as you can see, he built it query properly, and even for client sex, he was setting 2. But if you see in the database, it was selected like just int using, and in the comments it's saying 1 male and 2 female. So to make sure that this solution works fine, we have provided several SQL criteria which need to be certified. First of all, in the base input, you need to mention database type version, just to be sure that, because different databases using different functions, especially for data types and etc. Table and column names have to be clear and ambiguous identifiers. Otherwise, sometimes it can use different, instead of correct tables, he can use another one. Comments should be used to clarify and clear data, for example, customer sex. Primary and foreign keys should be used in case of non-obvious relationships. For tables with a big amount of data, you need to have indexes, just to be sure that the query run smoothly. And all the specified presented in the data should be added to the base input. That means, for example, if you have several versions of the same data in the table, like expirations is active when you have certain columns with the complex data divided by semicolons, or you keep JSONs inside the database. Also, you need to add limit during data load. This is also a good solution, just to be sure that you not load all the data. In some cases, for the big amounts, it could be relevant. And few security points which you need to remember. First of all, you need to use read-only privileges to prevent deletion and alteration of the data. You need to remove all columns containing some sensitive data like passport, client payment information, home addresses from the base input. Also, it will be good to remove all execution procedures, or to give not rights to the user to use them. Implement additional validation scripts before the execution. There are several frameworks which you can use, like LangGraph, GSQL parser, and etc. Also, it will be good to conduct training session with the staff which will be using this tool to prevent sending sensitive information to AI. And it will be good to maintain log of all data transmitted. and received to be later checked by a specified person. As a conclusion, we have achieved all goals which we put to ourselves. We have analyzed different business requests. We have defined classification for these requests. We have introduced possible solutions, and we have built a test program prototype to check it. So, yeah, that's all. Do you have any question?
Thank you. Any questions from the audience?
Could you please elaborate a little bit more on how the database schema is prompted to your artificial intelligence solution?
Yeah, so we have tested it in multiple schemas. Here in the basic input, you can see only one table. It was much bigger. We have tested it for different various domains. We have tested it financial, travel, some restaurant database, and we can run multiple queries which we faced in that businesses usages. Like when for the travel, we have asked different questions about hotel bookings from different regions, cancellations, breakfast fees, and etc.
If I may, I have one more question, which is a little bit more conceptual. This is a PhD symposium talk, so I do believe you have sort of a PhD topic back in mind before starting doing this presentation. What is the major objective of your PhD research project?
My PhD research project connected to the optimizing reports building using AI. This is only part of it when we talk about requests, responsive business requests.
Could you please elaborate a little bit more, for example, by offering research questions which you're looking at?
Yeah, sure. So we want to create a tool for businesses so they can use tools like ChatGPT in their business to get the answer in short amount of time instead of involving multiple teams, etc.
Don't you think it's a little bit more development work than a research project?
I believe it's both.
Okay, thank you.
Okay, thank you. Other questions? I have a question actually. So, you know that for now that SQL queries are generated rather well.
Yeah, really good.
And do you need to check them? I mean, when you put it in production, your system would be dependent on some outer LLM, and if it's go wrong, then who will be responsible?
The responsible will be, of course, the person who developed this model. Yeah, as our SQL criteria, we suggested to implement additional SQL validation using some frameworks, like LangGraph, GSQL parser. There are certain frameworks which allow to check the query. And yeah, because it's read only, we will prevent some alteration to the database. And yeah, also we suggest to keep all the data in certain place to responsible person to check them sometimes to be sure that model working fine.
Okay. So because there is a trend right now, that maybe I'm wrong, but that actually when you apply such kind of models, you need more efforts, not less, because you need efforts to generate SQL and you need efforts to check is it SQL correct. So it maybe would be easier to just write SQL without LLM.
It depends. When I faced like in multiple teams which I worked, a lot of people cannot write proper SQL.
So it's about money, cheaper teams, and you give them LLM. Okay, thank you.
Thank you.
Thank you. Let's go to the next presenter. So next presentation is Victor Lud and Volodymyr Pechenenko, understanding single function reentrancy attack. Please, floor is yours.
Okay, let's start. Good afternoon. My name is Viktor Rud. Together with my supervisor, Volodymyr Pischenenko, I wrote a paper titled Understanding Single Function Redundancy Attacks. Today I have prepared a presentation on this topic. The structure of my presentation is as follows. The main topics we will dive into are the analysis of vulnerable and attacking contracts and defense methods. We will start with an introduction and research methods, and at the end we will briefly summarize the results. Introduction. The figure illustrates the interactions of external ownable accounts with contract accounts. Contract accounts are synonymous with smart contracts. Externally owned accounts are user-controlled accounts on the Ethereum blockchain. So contract accounts can hold coins, fungible and non-fungible tokens. Their assets can have significant value. That's why it is crucial to ensure the security of contracts. One of the most dangerous types of attack is the reentrancy attack. It is characterized by its ability to completely drain a vulnerable contract. Currently, types of reentrancy attack. Currently, there are 5 globally recognized types of reentrancy attacks. Single function reentrancy, cross-function reentrancy, read-only reentrancy, cross-contract reentrancy, and cross-chain reentrancy. A brief historical overview. The increase in reentrancy attacks may seem surprising, especially as the field of security continues to evolve. I think this is likely due to the emergence of new types of reentrancy attacks. The goals of the study is conduct an in-depth exploration of single function reentrancy attacks, and contribution of the study includes systematizing, simplifying, expanding, and updating existing knowledge. Methods. The following methods were used to achieve the goals of the study: literature review, code analysis, theoretical modeling, manual testing, graphical representation. So let's start. Analysis of vulnerable and attacking contracts. The victim contracts. Quintessence of the single function reentrancy attack is a vulnerable function allows the attacker to call it again before effects are applied. Effects is when the function changes the contract states, i.e. variable values, and before the vulnerable function has finished its execution. When vulnerable function calls external account, it doesn't know what it calls. It may be externally owned account, it may be contract account, and finally it may be contract account of the attacker. Formally, this process can be described as transferring control flow to an untrusted contract. Untrusted contract can control execution flow by next fallback methods, fallback and receive methods. I have created a theoretical model of vulnerable contract called victim. The main component of vulnerability is the withdraw function. Let's look at the execution flow of withdraw step by step. First, study check stage. At the check stage, all necessary checks on the contract state and arguments are conducted. Interaction stage. In this phase, the function interacts externally, owned account and or contract accounts. Last stage, effect stage. At the effect stage, the contract's state variables are updated. Attacker account. I have created a theoretical model of the attacking contract called attacker. The main component of the attack is the function that calls victim withdraw function. Yes, along with inbuilt receive function. So let's look at flow of single function ransomware attack. Step 1. Initialize the reentrancy attack by requesting a withdrawal from the victim contract. Step 2, global function. It is function attacker attack. This one initialize reentrancy attack. And step 2, when victim withdraw calls caller of the caller, the receive function acts as a malicious component of the attacker contract. Okay, when victim withdraw attempts to transfer the requested funds to an address, the execution flow falls into the receive trap. The receive function contains code that recalls withdraw, looping the call and allowing within a single call, but with multiple nested calls to drain the victim account. The victim this is possible because the effect stage occurs after the interaction stage. Like you see, effect stage, it isn't a loop. Okay, let's see strategy and planning attack. First, what you need for good attack, it is minimizing the number of stacks. When in sometimes you need a strategy for successful completing the attack. For successful attack, sometimes you can attack into interactions, and a parallel attack doesn't make sense because Solidity doesn't support multi-threading. Attack from constructor is generally impossible because during the execution of the constructor code, the contract has not yet been fully deployed. Defense methods. Checked effect interactions pattern. Earlier, we discussed the role of each stage in the pattern. In this figure, you can see that the external call must come after the first two stages. In the order incorrect, the final stage effects does not occur before reentry happens. Checked effect interaction shortcoming. If another vulnerable function within the contract can call a function protected by the checked effect interaction pattern, the latter also becomes vulnerable. In this case, it results in cross-function redundancy. Okay. Mutexes. The concept is simple. At the start of the function, there is a gate that remains closed until the function is fully completed. It is gate, it is require locked on figure. This mechanism prevents reentrant calls. Full payment methods as essence before withdrawal assets are transferred to an intermediary contract. Exclusion of contracts accounts, defense methods. The first option is compare transaction origin and message sender. Text origin is always an externally owned account. The second option is to check the code size of the external account. External ownable account doesn't have code. Next defense method, transfer and send. The transfer and send methods are limited to 2,300 gas units, which is slightly less than what is required for nested call avoidance. If it is possible to avoid external calls to untrusted contracts, it is recommended to do so. Compiler version. It is recommended to use the latest compiler versions as they include the most up-to-date built-in protections such as underflow and overflow prevention. Pausable contract. The pausable contract from OpenZeppelin allows for the temporary suspension of vulnerable functions. Temporary pause. Vulnerable functions. I think that's all. 15 minutes and finished.
Thank you for very instructive presentation. And can you give a few real examples of reentrancy attack? I mean, so we can understand better.
Real example reentrancy attack?
Real life, yes.
It is case from history, you mean?
Anything from real life. I mean, I came to ATM. How I cannot be affected by reentrancy attack? I mean, is it possible to launch reentrancy attack on ATM or anything?
The main case reentrancy attacks, was in 2016 years. And
only two by your plot. Only two attacks were at that year. Yeah.
But the first reentrancy attack was the biggest attack, and it results hard fork Ethereum blockchain. So it was one Ethereum blockchain, but when
what was attacked on this famous?
It just was a contract account DAO, and it has a lot of Ether, and all this Ether is still.
Okay.
Because after that, community of Ethereum do hard fork, and they so was one Ethereum blockchain and it two Ethereum blockchain.
Okay, I understand. So the main target recently is electronic smart contracts and blockchain systems. So our real life mostly not affected. I mean, not everyone in real life used blockchain. Yeah, but ATM wasn't attacked. Okay, so let me go to the questions part. Do you have any questions, please?
Thank you for your presentation. I do wonder how it could be interpreted as a PhD research project. Is it a PhD research project, or is it a development project, or is it an exploratory project?
I think I will go in this term in my PhD process. So I think I will. Today I only talk about single function redundancy attack, but we have a lot of new type of redundancy attack, and we need more instrumental for automatic search this vulnerable in contracts. So I plan in research binary code, sort of.
So what is your motivation to dive into this topic? Is it the motivation to use attacks for getting more money? Or just protect accounts for not letting people like the previous one getting more money?
Just I like this theme.
So no rational motivation, just emotions. I do like Bitcoins and re-entrancy attacks on Bitcoins.
I don't like Bitcoins, like Ethereum blockchain, because Bitcoins doesn't have contract.
Okay, yeah. What are your expected results on such a PhD project?
My result in this work, it is how I planning. It is a summary of defense methods and summary.
I'm not sorry for interrupting. I'm not asking you about this paper. I'm asking you to think about your future. Just imagine that we are in 4 years from now, and you have written your PhD thesis.
I see.
Which result do you expect in there?
I think I will on this study. I will on this stage. I will study continue study vulnerability of Ethereum, and in this theme a lot of space and
are you going to extend the space or shrink the space?
I mean, I can find, I think, in you vulnerable, for example.
So you are still rational. At the end of the 4th year, you'll be going to use the result to get more money from those contracts. Okay, thank you very much.
Thank you.
Thank you. Any other questions from audience online or offline? No? Okay, I just want to encourage you to make a presentation a little bit more energetic, okay? So we can learn about this in a more exciting way. Okay, thank you. Next and last, I think, for this section presentation is, sorry, I need to find it, yeah. So this is Alexander Barsky, Ilya Ilyin, and Anna Zazula modern technique of distributed computations will be presenting. Okay. Yeah. Please, 14 minutes, 15 minutes as usual, and 5 for question.
Mirrors never performed on the stage. How to connect? Yeah.
Just present your share the screen or yeah.
I think it's. If I stand like this, can you hear me? So the sound is good. Okay. This my PDF. It's working. This. Take some water, I'm sorry.
Huh?
Some water, please.
Water? Water is used
For one. In case it's needed. Yes. Yeah. So I will start from present ourselves. I'm Alexander Barsky, and today I want to present our work, which is called Modeling Technique of Distributed Computations, which we made with other, which this work was made, and we will continue with Ilya Ilin and Anna Zuzula, other PhD students of the same faculty where I'm studying. The faculty is School of Mathematics and Computer Science of Krazia National University of Kharkiv. Next slide. So on the slide you can see the above context of this presentation. Yes. And we will begin from the motivation of this paper. Yeah.
Or directly into microphone, because otherwise they...
Now is it okay now? Okay. And for example, like this, it's also okay. Yeah. Yeah. Okay. So we will begin with the motivation behind this research, where we will explore key topics such as growing trends of cloud computations and the challenges that they pose. We will also discuss the advantages and disadvantages of distributed computations and examine both static and dynamic software analysis methods. Next, we will move on to the conceptual model of distributed computations. And I'll present a model that describes how distributed computation are structured and how the various components interact with within this model. Then the mathematical model section, where I will introduce labeled transition systems, or LTS.
which serve as a mathematical foundation of our analysis. We'll look at how LTS applies specifically to distributed computations. After that, we will discuss the research objectives, and the presentation will end with conclusions. Next slide. Yeah. So let's start with well-known general facts, which means cloud computing is now essential, offering scalable and cost-efficient solutions, replacing traditional infrastructure. It drives innovation by removing hardware limitations, and it's widely used for heavy computations in AI and Internet of Things. However, it also brings new challenges in managing and analyzing these computations. On this slide, you can see the main features that distributed computations bring to our lives, that are high availability and redundancy, fault tolerance, and disaster recovery, and evolution of paradigms, which means cloud computing reflects an evolution shift towards distributed data-centric and service-oriented computing paradigms. About advantages of distributed computations, they offer key advantages like scalability and performance with when you perform parallel tasks, and resource sharing. It also supports geographical distribution, reducing latency and improving fault tolerance, ensuring systems remain operational despite failures. Slide. About disadvantages of distributed computations. It's always some complexity, concurrency issues, network overhead, data consistency, and always problem with debugging and testing. Because debugging and testing distributed system is non-deterministic. Yeah, so a second. It's more difficult, yeah, this is written on the slide. It's more difficult compared to centralized systems due to the complexity and non-deterministic behavior of concurrent process. And let's start by discussing static software analysis. So we have distributed system, and we have some method to analyze this and test. Static analysis involves examining the source code of a program without actually executing it, because sometimes we cannot allow ourselves to run the system and see how it works. We just want to know it before if we have some issue. And on the slide, you can see also tools and techniques which can be used for static analysis. For example, specialized tools like COG are used for formal verification, allowing programs to be designed according to, say, formal specifications. And modern standard analysis builds models and uses formal tactics to prove lemmas, theorems, and properties. About dynamic analysis,
On the other hand, dynamic analysis involves examining the code during runtime in order to detect problems like memory leaks, threat competition, and security vulnerabilities. And this issue that can significantly impact the performance and security of the software. There are several techniques used in dynamic analysis. They are debugging, profiling, memory analysis, fuzzing, and runtime testing. While dynamic analysis is powerful, it has its limitations. For instance, we can never fully guarantee that the program will work correctly in all scenarios, because sometimes it's impossible to test every possible input or state. That's why dynamic analysis is often paired with static analysis to provide a more comprehensive approach to software verification. On this slide, you can see some works on the topic of distributed computations. We will just point out that later we will mostly operate labeled transition systems, which were also used by Robin Miller in the calculus of communicating systems. Our research aims, the primary objective of our research is to develop a comprehensive model that effectively combines static and dynamic analysis methods for distributed computations. This approach aims to leverage the strengths of both techniques to create a more robust and versatile analysis framework one. We will also be focusing on empirical studies during the development of specialized toolkit. This toolkit should be capable of performing both static and dynamic analysis across various graph topologies of network interactions. Next slide. So on the slide, you can see I try to explain. Let's discuss this conceptual model. I hope it can be read. So this is conceptual model of distributed computation, as shown. Distributed computation involves at least two isolated sequential processes, which we refer to as actors. The model consists of two main concepts. First, a family of actors. Yeah, I hope it. Can you read? Okay. So a family of actors, and second, the communication system, which is responsible for enabling the message interchange between those actors. The conceptual model forms the basic for understanding how distributed computations operate in system where processes are isolated yet need to communicate effectively to perform computations. So we have no shared memory in this conceptual model, just actors, and they communicate with what we will explain in 1 minute next. This is another scheme. Moving on to the interaction between the communication system and the actors, which is depicted in the diagram. Distributed computation is represented as a sequence of events, which can be either finite or infinite. The communication system operates in a continuous loop where it first receives a message from one of the actors. Then it processes messages and sends it to another actor within the system. Similarly, each actor also operates in loop. Each actor receives messages from the communication system. An actor executes its sequential behavior based on the message's content. And once the task is complete, the actor sends a new message back to the communication system, continuing the cycle. Let's discuss the concept of label transition systems, often abbreviated as LTS. And an LTS is a mathematical model that is particularly useful in specifying discrete sequential processes, which is why it's widely applied in computer science for modeling computations. We define a labeled transition system as a tuple denoted, you can see S, I, A, E on the slide, and also the definitions of S, set of whole members are called states. E is a set of members.
About 2 minutes left.
2 minutes left. Okay, I will be short. This slide, okay. So we can see definitions, also definition of the terminal state. Yeah, and also the main thing that transition and event can be useful interchangeably. On this slide, this is 14. Also some definitions of event chain and definition of the run of the transition system. So event chain is the sequence of events, and where each next event leads to the next state. And run of the transition system, this sequence can be called run if we have initiality, continuity, and maximality. The message model, just some words. How can the message be formally represented? It's a tuple of little s, r, I, and v. S is state, R is some, S is actor, R is actor, E is just some number, and V is what was V?
I'm sorry, but time is over. Can you go to conclusions?
Yes, just a second. Let's find it. Just a couple of words. So also we have this model communication system, and the system can be configured. Then, yeah, 17 from 20. Just a second.
I'm sorry, but it's your first time to presentation like this?
Not first, but
You know that when time is over, time is over. Please
Yeah.
go to conclusions.
conclusion. Yeah. Okay. So today we emphasize that.
Okay, I think we can read it.
Yeah.
Maybe make it simpler. Any questions, please? Yeah.
Thank you for your very nice presentation. Could you please go back to your first UML diagram?
Of event.
UML class diagram of something. Is it about an event? It's entitled distributed computation, which I believe is a process.
Is it what?
Computation is a process, it's not an event, isn't it?
Computation is not a process?
No, I'm stating that computation is a process.
Yes.
But you call it an event.
No. I maybe. No, I didn't use. No, event is event. Computation is a sequence of.
So the question is, do you think that this diagram you have here, this UML class diagram, is a complete diagram to model a computation?
So the question is if we need to add something to be more.
Yeah, I mean, you may treat it constructively if you wish. For example, I do see that computation contains actors.
Yes.
Triggered by events, and events are acting, sending, receiving. Something like messages. This is it.
Yes. And everything, so for example, some computation can be performed inside the actor, and the results, the input of the computation arrive to the actor in messages, and then the output arrive from the actor in messages also. So some computations are performed in actors, not only in events, messages.
But the diagram is wrong. Because here, the diagram says that the computation, the stop at this
computation, we have this computation. What we can see is the computation of the whole distributed system.
I don't care.
Yeah.
The computation is the process of computing something.
Yes.
Transforming inputs into the outputs, right?
Yes.
Okay. So the diagram says that it is a sort of aggregation of actors and computation systems. Where is the process? Because actor is not a process. Computation system is not a process.
In this case, actor is a process. We called it actor, but it's process.
Okay, so I have no more questions. Thank you.
Any other questions? No? I maybe have some advice to train before you start to present, because when you read your presentation, I had a feeling that you saw it first time actually. So you saw slide and trying to read from the slide. So idea of presentation is not reading from slide. Idea of presentation is writing text and illustrate it with slides. So because if you just reading from slides, that no point of presentation, you see? Okay. So please next time just try to be prepared. Okay, thank you. I think we can finish on this, and this concludes our session, and next session will be after the break. Thank you.